How do you grab stuff in VR? There is a pretty simple way you can do it in the XR Interaction Toolkit using OpenXR, but I'm not a huge fan of doing it that way because people have run into a lot of problems where when you move, the object that you're holding will separate from your hand and go in a completely different direction. And if you want to do a physics kind of interaction, those don't really work too well, and there's no built-in two-handed interaction. So how are you going to do that? Today I'm going to show you how to do a physics grab and have it so that you can grab any object at any point on the object and your hand will grab to it accurately, and you can move around with that object still holding it and not have any issues with that, and it obeys proper physics. So if I'm holding a 2x4 from one end, it's going to swing down on one side and the physics are going to act appropriately like that. Be forewarned, this tutorial is a little bit code heavy. I'm going to walk you through how to do each step, but if you don't want to write it down, or if you're just not the coding type of person, you can support me on Patreon and download the whole project right there. So if you would like to take that route, the link is in the description. I would really appreciate your support. It helps me pay for VR headsets and that kind of stuff. So without further ado, let's jump into the tutorial. We're actually going to be starting out with a project that I have already done a tutorial about, the realistic hands that slap. That video is going to be up here in the top corner if you would like to catch up and get to there. I'm going to go over the code very briefly and show you it on screen so you don't necessarily have to go back to the other project. But if you want to learn how to set up a project or something like that, this is not that tutorial. So I'm going to go in here and copy and paste this project and rename it to a different name. So this tutorial is going to be Realistic Hands Part 2 Physics Grab. So I'm going to open up Unity Hub and then we're going to go find that project. So I'm going to hit add, go to the project, Physics Grab, and open that one up. I have already converted it to the version that I want to use, which is this 2020.3.6, which is long-term support. All right, let's open this one up. All right, let's go into scenes and open up the scene from the last tutorial. And you'll see we've got a cube, two cubes, one's grabbable, and we have the hand XR rig in here. I'm gonna drop the icons down. So we've got this XR rig over here it comes with the left-hand controller and the right-hand controller. These are set up with direct interactor and sphere colliders, and then we have this grabbable object here, which has a box collider, a rigid body, and a grab interactable component on it. So to help me out a little bit, so it's a little more appealing, let's go into packages, and I'm going to install a wrench package. So I'm going to search in my assets. I'll put the link to this asset down in the description. It's a free wrench, and I'm just going to import that. And yes, I want all the shaders and everything. So let's grab this wrench and put it in here. And it's giant. Scale that down a little bit. Let's do 0.2. That's a little bit of a larger wrench. So I've got that wrench in here. Let's go through and add some mesh colliders that are convex to each of these components that have a mesh. And then on the wrench itself, we want to add a rigid body, and all of these settings are fine. And then we want to create a new layer, and I'm just going to call these grabbable. We go back to the wrench and set the layer to grabbable. And I only want it for this object, not the children. Once we get into the code, we're going to use this grabbable layer to determine that this is an object we can grab and then perform actions on it. So this is going to help us determine between things we can grab and things we can't. Now let's go over to the code. So we're going to go back into assets, scripts, and then the hand. Open that one up. There's a few changes we want to make inside of this hand class. First off, I'm going to delete all of the animation stuff. So up here when it's requiring animator component, delete that. Delete all of the animator variables. We're going to delete the animation stuff from the start method, delete it from the update method, and then the set grip method can get deleted, the set trigger can get deleted, the animate hand method can get deleted, and the toggle visibility method can get deleted. And then there's a couple more improvements we can make on the already existing code we have for the physics. The first one is inside of the start method, when we are setting the body mass and all of that stuff, we also need to set the body max angular velocity. We're going to set this equal to about 20. The default is 7. So the reason that some of you have been getting a kind of like drunk hand effect where your hand doesn't quite catch up to where your controller is. That's because the maximum angular velocity is set to 7. So we're going to bump it up to 20, and that should fix a lot of those problems. And then down here in the physics move method, we want to, instead of adding the position offset to the follow target position, we want to take the follow target dot transform point and add the position offset to that. So this essentially converts it from local space to world space. And that's why the offsets have been a little bit off. So like you will get it in the right position and then you rotate your hand and then your hand's out of position a little bit. This should fix that. So now when you adjust it, you're adjusting it for that particular world space. And now when you turn your hand, it's not gonna be off. It's the best way I know how to describe that. It's converting it to world space and then adjusting that. And that's really the change we needed there. So let's start working out the grab code. First off, we're going to change this follow object to be just the controller. So we're gonna change this to an action-based controller, and that's gonna add this using statement up here, using unityengine.xr.interaction.toolkit. So if your action-based controller is underlined or red, then make sure you have this using statement up top. And then instead of follow object, I'm going to change this to controller. And that means down here in the start method, we're going to need to change this follow object to controller.gameObject.transform. And then I'm going to add a couple spaces here just so it looks a little nicer in the editor. So a space up top, a space after the follow and rotate speeds. Let's add another space here. We're going to need 4 more serialized variables. We're going to have a private transform palm, and this is going to be a game object that we set that's going to be right on the palm of the hands, so we can set that to be the position that we want to make contact with. We're going to have 2 serialized field floats. We need a reach distance, and that's going to be equal to something like 0.01, and then we need a join distance, and we're going to set that equal to 0.05. And then 1 more serialized field, and this is going to be a layer mask, and we're going to call this grabbable layer. So the palm is going to, be where we want to pick things up. The reach distance is how far away we want to be able to grab things. The join distance is going to be how close to your hand do you want the object to be bound. So at what point is it going to be joined to your hand and effectively grabbed? And then we need a grabbable layer, which we set up a little bit earlier to determine which objects we can grab. And then we need a few more private variables. We need a bool that says, is our hand grabbing anything? We need a private game object, and this is going to be the held object. So if we're holding something, we're going to fill this variable with that object. We need a private transform, and this is going to be the grab point. And we'll specify this when we press the grip button, and it's going to send out a sphere, and then where that sphere hits that object, we're going to specify the grab point as the closest distance that the object is to your hand, and use that point as the connection point. I'll explain that a little bit better later. And then we need 2 private fixed joints. So I'm just going to call these joint 1 and joint 2. And this is going to be a joint that connects the hand to the object and a joint that connects the object to the hand, back and forth, so it's a solid connection. And then let's go down here to the start method. Inside of here, we're going to subscribe to the action when the controller grip button is started to be pressed and when the controller grip button is exited and canceled. And I'm going to call this input setup, and this is going to be controller.select action.action.started. And you see this little lightning bolt here. Your IDE may not have it, but started means that's an action that we can subscribe to. And then we're going to make a new method, and we're going to call that one grab. And then we need to also subscribe to the release. So controller select action canceled is the word for that. Plus equals released. And now we need to make a grab method that is called whenever the grip is started to be pressed, and then we need to make a release method that is called when the grip is released. So let's scroll down here below physics move. I'm gonna make a little more space. I'm gonna say private void grab, and then inside of the grab method we need a callback context, and we can just call this context. We're not actually going to do anything with this context, but it is required to have this input inside of your parentheses because we're subscribing to it, and this is what it gets sent. So now the player has pressed the button and told, okay, so now the player has pressed the button and told the code that, hey, I want to try to grab something that's in front of me. So first we need to check and see if the player is already holding something and if they're already in the process of grabbing something, because we don't want to, interrupt and restart the grabbing process. We want them to fully release and then try to grab again. So first off, we're going to have an if statement and check if they're grabbing something or if they have a held object already. And if either of those are true, we want to return. So just exit out of the method. If it passes that check, we want to do what's called a overlap sphere, and that's going to give us a list of colliders. So we're going to do a collider array colliders, and that's going to be equal to physics overlap sphere. And we're going to start out where the palm position is, and then the radius of the sphere is going to be the reach distance, and then the layer that we want is going to be grabbable layer. So what this does is sends a sphere out from the palm position of a radius of whatever the reach distance is, and then the colliders that it returns are only going to be colliders with this layer. That way we're going to collect all of the objects that are within the radius that are grabbable. So that's what this colliders is. And we could rename this a little bit better and call it grabbable colliders. And then we need to do a check and say, are there any colliders? So if grabbable colliders.length is less than 1, then we want to return. So exit if we tried to grab and there's nothing that is close enough to grab, we're just going to exit the grab method. Now we're going to make a variable called object2grab, and we're going to set that equal to the first collider that we selected. So grabbable colliders, set that to 0, transform game object. Now the next trick is to find the rigid body, because that's what we actually want to grab and join to. So we need to make sure, like the wrench, we don't want to grab onto one of the sub meshes, we want to grab onto the actual wrench object. So we need to check and see, does this object to grab have a rigid body? So we're going to make a new variable called object body, and then we're going to say object2grab.getComponent rigid body. And if that's true, so if object body does not equal null, there is a rigid body on that object, then we can set the held object equal to the object body dot game object. But if not, that probably means that this is a child object and we want to grab the parent object with the rigid body. So we're going to check and see if the parent has a rigid body. So then object body is going to be equal to object grab get component in parent rigid body. And then we need to do another check. If object body is not equal to null, then we're going to set the held object equal to object body dot game object. And then the else, we're going to just return. Leave the method if both of those are false. And then at the very end, if we're still inside of this method, we want to start a coroutine, and we're going to call this new method grab object, and we're going to send the collider from the original overlap sphere. So this is grabbable colliders number 0, because this is going to help us find the closest point. So now let's make a coroutine. So we're going to make a new method. This is going to be a coroutine, so we're going to have a yield statement inside of it, which means it needs to be enumerator, and we're going to name it grab object, and we want a collider to be sent with it. So as soon as they're inside of this enumerator, inside of this coroutine, we want to set is grabbable equal to true, or is grabbing equal to true. That way we can't start grabbing again as long as we're inside of this method. We're going to need to do a few things in here, so I'm going to write out comments to kind of block out what we need to do. We need to create a grab point. We're going to move the hand to the grab point. We're going to use our yield statement to wait for that to happen, because that may take a frame or two. We don't want to just instantly attach, because then we're going to be attached to the object from a distance. So we're going to use the yield statement to wait for our hand to get to that point. And then once we get to that point, we're going to freeze the hand and the object's motion. And then we're going to attach joints, and then we're going to reset the follow target. So let's walk through this step by step. We want to create a grab point. We already set that variable. It's going to be grab point. We're going to set this equal to a new game object, and we want it to be the transform, or the position of that object. Next, we're going to set the grab point dot position equal to the collider closest point to wherever the palm position is. So this is going to draw a line from the palm to the collider's position and figure out what the closest point on that collider is to the palm. Then we're going to create a grab point, move the grab point to that spot, and then we're going to use the grab point as a reference to connect the hand and the object. We're also going to parent the grab point, set the grab point dot parent equal to the held object dot transform. All right, the next section, this is pretty easy. All we have to do is set the follow target equal to the grab point, and our physics code up in the update method is going to automatically move the hand to that point because we're following a follow target. Next, we're going to use our yield statement, but we're going to put it inside of a while loop. We're going to say while the vector3 dot distance between the grab point position and the palm position is greater than the join distance. And we also want to check to make sure that we're still trying to grab, because if we're using a yield statement, then the player could have released at some point, and we don't want to run the rest of the code if the player's not trying to grab anything anymore. So that's why we add this in. Then we're going to say yield return new wait for end of frame. So what this does is we'll check the distance, and if it's within that join distance, it will continue on to the rest of the code. But if it's not, it's going to wait for the end of the frame, wait for it to update, and then it's going to start back up from this point and then go back through the while statement and then check again the distance. So it keeps checking the distance, but this isn't in an update method, so it's not going to be continually going, which is nice. And that's why we use coroutines, is because we don't want to overload the update method and cause a ton of calculations and stuff to happen when we don't need them. So this only goes at a specific point, and that's the whole point of yields and coroutines and whatnot. Now we need to freeze all of the momentum, rotation, motion, everything, because if the hand connects to the object and it's moving very fast to get to it, then it's going to cause weird physics behavior and your objects are going to go flying all over the place. So once we're in that tolerable join distance, we want to stop the motion of everything, attach the joins, and then now the motion is dictated by the player instead of by whatever motion was happening. So first we can set the hand's velocity equal to a vector3 dot 0. Then we're going to set the hand's angular velocity also to 0. And then we need to actually get the rigid body. So we could just do a get component rigid body here, or we can just send it inside of here. So now, since we've already gotten it up here, it's going to be called object body. When we do this coroutine grab object, we can send the target body as well, or we're calling it object body. We can do the object body. So that will send the rigid body into this method, and now we can just grab it and set the velocity also to 0, and the angular velocity as well. And then we're going to need to do actually a couple more things that I didn't comment on, but we want to, still using the target body, set the collision detection mode equal to continuous, and then we also want to set the interpolation mode to interpolate. And now it will behave just like our hands. We want it to be continuously updating the physics every single frame, not just passively. Now we need to attach the joints. So first we're going to do joint 1, and we're going to set that to game object, add component, fixed joint. Then we want to set the connected body equal to the target body, and the brake force going to be equal to float positive infinity. And same thing for the brake torque. Float positive infinity. Now it can't be broken, and you can adjust these numbers, change this out with a variable instead, and if you want to have something be able to be ripped out of your hands, you could adjust these variables and set them to something that is more reasonable. You'd have to play around with the actual values and figure out what that would be, but that's how you do that. And then a few more things for joint 1. I'm going to set the connected mass scale. Connected mass scale is going to be equal to 1. The mass scale is going to be equal to 1. We want to disable collision between the two objects that we're joining, and we want to disable pre-processing. So these are essentially the weight that you want to set the mass to, and so we want everything to keep its original mass, so we're going to keep those at 1. We don't want the objects that we're connecting to collide in any way or have any kind of interphysics. We want it to behave as one object, so we're going to set this to false, and then we're just disabling pre-processing between these two because we don't need it. Then I'm going to highlight this whole thing and then press Control D, and that's going to duplicate it. And then this is a cool trick. I'm using JetBrains Writer, and I believe this works in Visual Studio as well. If you press Alt, Shift, and then the up arrow, it will extend your cursor, and now my cursor is over like 6 lines, and so I can hit backspace and then 2, and it will change all the joint 1s to 2, and then I can delete this line here. And that's a super easy, quick way to adjust all of those values. And now we need to go back here, and in instead of on the game object, we want this to be the held object. And then instead of connecting to the target body, we're going to connect back to our body. So this join is from the hand to the object, and then this join is from the object to the hand. We're kind of doing a cross join just to make it a little more stable. And then down here at the bottom, the last thing we need to do is reset our follow target. We're going to set that back to the controller, game object, transform. Make sure to save. So this is our grab object. We need to do one more method, and that's going to be release. This one can just be a private void, call this release, and we're going to want to do a callback context with this one as well because we're subscribed to it up in the start method. And then so when the player lets go of the controller, we want to break all of the joins, drop the object with whatever physics are currently applied to it. So first we're going to say if joint 1 exists, we're going to say destroy joint 1. And then I'm going to do the control D trick to duplicate that, update that for join 2. And then we also want to say if grab point is not equal to null, then we also want to delete the grab point. So we're just going through and cleaning up all the stuff we created when we made that joint in the first place. And then we want to check and see if there's a held object. And if there is, we want to get the rigid body of that object. So we're going to say held object, get component, rigid body, and then we're going to reset all of the collision and interpolation modes, reset that back to discrete, and then we're going to set the interpolation back to none. And we're not going to delete held object, but we're just going to set it to null. If we deleted the object, we're actually deleting, the hammer that we're throwing or the wrench that we're throwing. So we don't want to do that. We just want to delete the reference to it. So we're setting it back to null. And then finally, we'll set is grabbing equal to false and make sure the follow target is following the controller. And there's the release method. We cleaned up everything and reset the is grabbing and follow target. So let's save it, go back out to Unity and adjust a few things, set some variables and see if it works. And if we go to console, we see we're already getting a couple of errors, and that's just from the hand controller. And actually we're not even using hand controller, so I'm going to delete that. And then we're going to clear the console, and let's open up one of the hands and go in and check the hand script. So we want to set the controller. So this is the left hand, so we want to set the left hand controller. Follow speed, rotate speed stayed the same. We don't have a palm yet, so let's make a palm. So I'm going to open up the layer prefab and then open up the left hand. Nope, not what I wanted. And we're going to hide the right hand, and then inside of the left hand we want to create a new empty game object. We're going to call this palm and set that in the middle-ish where the grip is going to take place. And then we also want the x-axis to be pointing out. I'm going to rotate it about 90 degrees, a little bit. There we go. Anything that we try to grab is going to attach to this point on our hand. That's pretty good, so I'm going to copy it and then disable the left hand, enable the right hand, and then let's paste the palm on the right hand and then do a little more fine tuning, and we'll need to flip it around. There we go. Let's save the player model, and then let's go back out to our hands. Oh, that goes inside. Yeah, there we go. Yeah, so palm is inside of right hand. Save that back out. So now we're in the left hand. We're going to set the palm, so just drag and drop, and then grabbable layer needs to be grabbable. And then let's go over to the right hand, set the right hand controller, the palm of the right hand, and the grabbable layer is grabbable. Let's save all of that, go up to the wrench, and there's one more thing we need to do with the wrench. When I said I didn't want to have children, when I said no to this option here, change children, I actually should have said yes. So we want to change all of the children because we're going to key off of the collider and the layer. So all the game objects with a mesh collider need to also have a grabbable layer so that our code will work with it. All right, let's jump into Unity and try it out. I've got my Oculus Quest in link mode, and I'm just gonna hit the play button and run it in here. So we're in a test, and it's complaining about not being able to destroy the transform of the game object. So let's go down to the release, and I think it's saying this because grab point is actually a transform, so we want to destroy the game object of grab point. And that should solve that error. See if there was anything else. And I also realized that I can't move inside of this project. So I'm gonna go to the XR rig, add a locomotion system, drag the XR rig into there, and then I'm gonna add a continuous move action-based provider, drag the locomotion system in there, and then I'm gonna do a continuous move turn provider. drag the locomotion system into that one too. And then also I want to move with my left hand, so I'm going to uncheck the right hand, and then the same thing with the turning. I want to turn with the right hand, so uncheck the left. And now I should have motion as well. Let's hit play again. So as you can see, we still have physics in my hand, but then I can also pick up. And you'll notice if I get close enough to the object and then picks it up and then brings it back. So this is useful for, let's say you have, let's say you want to try to pick up an object, but you're reaching your hand through something and the object's too big to pull back in. It's not going to just teleport the object back into your hand. It's going to collide with that surface. So you're not going to be able to get that. And then also I have a two-handed grip, so I can grab it with this hand as well. And you can tweak the, you can tweak the distance for your join, and so you can make it faster or slower. I'm getting a little bit of lag because I'm using wired Oculus's AirLink right now. And one more thing in here, it's also complaining about grab point being deleted when we let go, but then it's also trying to reference it. So inside of here, we're going to say grab point does not equal null. There you go. With this script, you have the ability to physics grab objects, do two-handed grips. You can play around with the reach distance and join distance to figure out how far or close you want to be able to grab things and how close you want the hands to be when they attach to something. And we're going to make this a little bit better in the next video in this kind of physics grab series that I'm doing when we do procedural grip. So the fingers are going to wrap around the object and it's going to look much more realistic and lifelike. So that'll be the next video in this series. Thank you so much for watching. I really appreciate each and every one of you. If you want this code or the project just to download, because I know the code is kind of complicated, you can support me on Patreon. The link's in the description. I would really appreciate it. Or you can just throw a comment down below and I'll reply to every single one. So if you just need help on one or two particular things, just comment below and I'll answer them. I really appreciate your subscription and likes on the video, and I'll see you next week.